Hello, Dr. Mike here. This is a quick look at the Titanic Part 1 and really more of a study about how to approach this. So this is for my Python class. And this is a quick video maybe to show you my thoughts on it to help you sort of get started. And this process can be taken to Part 2 also. So first off, again, as you see, when we get to this part of the course, it really is about you coming up with the process, your own process, to answer the questions that are posed to you. So um, for this one, for Titanic Part 1, we have 3 questions currently at the time of this recording. We're looking at, from the Titanic data set, which are provided, what the probability that a child in the 3rd class, 10 years old or younger, survives. So probability, percentage, chance, probably of that. Then we're looking at some rates. How much do people pay to be on the ship in average? What's the lowest and highest fare paid by passenger class? So we're going to go over the process here, how to approach it. So first off, I'm just going to go and load NumPy, Pandas, Seaborn, and Matplotlib. I know I use all these, but this is like my common stack of things I typically will just go and load those. Now I do have a second data set here. You don't have access to this. It's actually on Kaggle. It's a training data set they use. It's sort of a larger Titanic data set. And I'm going to load it because I'm going to show you an example of something to check for. But I'm loading mine as titanic.csv, and that's on my local disk. I'm going to call it tdata, and I have one called train. So I'm going to load train.df with training, and I'm going to do a pandas read CSV. So I'm using pandas a lot for this. I'm leaning on pandas. After you sort of come up with your own process, use whatever works for you. I'm just going to go and show you how I might approach this. So you're not required to use pandas. Use whatever you like. So again, I love both those. Now, an important thing is, and this is what I'm using the train set for this, is we want to check for bad data, check for null values. And one thing we can do is we can just do a summary of is null. So we can take is null, we can pass it to sum. So by doing this, I actually have 177 null values in age in my data set. Now, if I have to describe the data itself, it's 891 observations or rows. So 177 of those are bad. We can see it right here. So even if I just do describe on it, this is why we say you want to explore your data first. Just see the max values, min values. Make sure there's nothing out here that's like way out of the average. I mean, 150 million or something like that, or just some crazy values. So we're looking for bad data. In this case, we do see that there is some null data in age here. So, and of course, we can actually look at those if we wanted to. We can see there's a bunch of bad data inside this data set. So you need to figure out how to work with this. Now, Pandas itself, I might be able to feed this in and do regular analysis like describe and so on. And a lot of times it won't error on this. Pandas is really well at handling, and this will skip over nulls. So, but an important thing is in your research, you want to maybe document this and show there were null values. Maybe if you did remove those, if it is null, you removed them and created a second data set called main1 or whatever, and you use this chunk of code to remove those data, the 177 bad observations. So that's how you might want to approach bad data. So now our CSV, the one that you're provided for, I provide you, same thing. If I go and I can bring it in, look at it, I can get the info on it. Now I see there's 887 of everything. So I'm using the info in this one, and I can also just do an is null. And I see there's no nulls. So your data set you've been provided through my course has already been scrubbed. But I want you to just realize that I can do describe on it, and you can see. So there's no nulls, 887 observations. So approach your data, take a look at it. Again, this is a training data. You can find this on Kaggle. It's called train.csv, and it's a training data set. I think it's used for machine learning, which I'm not going to approach in this topic here. Okay, so let's go back up here and look at our questions. So again, probability. We're going to come to that one last, actually. It's probably going to take a little more steps. But how much should people pay be on the ship in average? and what were the lowest and highest fares paid by class. So this was pretty straightforward. How much people to pay to be on the ship. We can actually get this and this in the same output. Now, an important thing is in your output, when we say average, you need to make sure you communicate what average you're using, mean, median, mode, for example. And also when we communicate out the units here, it's Great British pounds. It's not the dollar sign, what we see as the US dollar. So we want to make sure we're precise with our output. For rate paid here, I'm actually using a dot copy. Copying from the main data set, just the class and fare. I'm creating one called rate fare. And this uses an Pandas data frame copy option here. So you can see I have just the rates and the class. And now I can group this and call this data frame rate fare, DFRF, call whatever you want. And now if I describe this data, I have by class, I have the count, I have the mean average, which is what I need, and I have the max and the min. So we do see a bunch of people did get on with zero pay. Not on the actual amount, but we do see there were some free tickets given, probably not too uncommon in all classes. So to answer this, in this case I'm using a markdown cell. If you've been using code comments, start using markdown cells. You want to use markdown cells and you want to run them to make sure that you get the nice markdown out. Like you can see here, this is actually, I don't know if it runs in Colab, but 2 pound signs gives me this, like header 2 and so on. You can see here, 3 pound signs is header 3 and then dot and so on, and italicized. And you can see I did some cleanup here. Make it look nice. But the first class, the average mean, very important you communicate that, Great British pounds, not US dollars. I put 84. Now I'm just taking the main amount. I'm not going any decimals. You can if you like. You can either round. You might want to communicate that, maybe round it up, round it down, or just truncated, or just take the $1 million amount. Second class got 20, and third class is 13. And then the highest paid is over here. And the lowest actually was 0, so there were some free tickets given in all classes. So that process does answer our first and second questions, so we can actually communicate that. Now the first question itself was, percent chance third class 10 and under survives. Now let's actually review some aspects here. It's very important we look at this. First off, of course, third class. We know only third class. And it's 10 and under, not under 10. I know these are really finite details, but if we do 10 and under, so less than or equal to 10, if I just do less than, this will change. This could change the output. This could have probably less, of course. It could be a group of 10-year-olds I totally forget about. So make sure we understand the question, 10 and under. If we were not sure, it says around 10 or 10 or just 10 years and under. Somehow, if it's not stated correctly, then you want to state in your output that we used 10 years and under in our analysis. So I'm using this pandas .loc, and I'm creating basically a Titanic child data frame. I'm taking the main one, and I'm sort of slicing off survived, class, and age. I'm going through and I'm sort of carving this thing down smaller. So I'm taking this again, and I'm going to go ahead and say, just give me where age is 10 and under, and give me where class is equal to 3. So third class, 10 and under, and I'm out with those columns. So you can see here I got they survived, which I know looks like a Boolean-based value. It really you probably just come across as a integer, but 0 we can assume means did not survive, and 1 means they did. We have the age here. Looks like that's a float value, and we have the class, which is probably also a integer. And we can of course do a describe on that if we wanted to. Now I'm going to create a data frame for the ones that survived and the ones that deceased. Again, I'm using the .loc. LOC, of course, is using our data frame slicing per se. I'm going to go ahead and say survived is equal to, and make sure we use double equal to 1, and of course survived equal to 0. So I have a data frame for each, and I can get the head gives me the first 5 rows. I just get a sample, make sure I'm seeing that. I can look at the whole thing if I wanted to. Let's take that off. I get the full thing. So go ahead and just take a peek at your data as you process it. And now I'm actually using the length. Length gets a number of items. Now there's different ways to approach this. You can summarize it, you can count, and so on. I'm creating a couple of variables here. Total children, which is an integer, and children survived, which is also an integer. I'm getting basically the count of each one of those. And I have, you can see here, I have 53 total children and 22 survived. So again, part of my process here was I want to also know my algorithm I'm going to use. In this case, the probability. Survived divided by total times 100. It gave me a percent. I'm going to communicate a percent chance here. So taking that, you can see I put that in the code. Real simple coding here. Can I use parentheses to make sure that calculates first, then I do multiply by 100. And I'm getting what looks like a 41.5% chance. So if I just take the non-decimal values, 41% chance that a 10 or under in third class would survive based on the data set. So that's how I approached it. Again, as always, approach this. Now, do I need any visuals? Of course, I would probably type this up. I would restate the question, and I would go ahead and put 41%, of course, as part of my answer. But you can see I have the basis for my answer right here. Now, again, you can do visuals if you want. I got a bunch of stuff here which I don't think I need. Matplotlib, I did a violin plot. I don't know if this will work here. Let's see, I got AgeSir. I need to create AgeSir. Yeah, so I could have copied AgeSir, but you know, if I let's see, this loads here. Okay, so there's a lot of there's moving parts here to get this. This is a violin plot. This is a seaborn, and again, does it maybe communicate? It does maybe visually. I don't get precise numbers, but I can sort of see female that survived versus male that survived by class. Again, it might be confusing. You might use a bar chart instead. But in the aspect for this questions, you don't really need great visuals, do we? All we need are the simple answers. So this right here. And then I would just do a markdown cell and say, and restate the question and say 41% chance of survivability based on the data iris.csv that had 818 observations. You know, to get RA is a total of 800, and we had 887 observations. So you can go and put that if you like. Again, not required. It depends how much you want to communicate across. But all in all, you can see my process here. Now, again, you may come up with a different process. That's fine. I want you to explore your own way to approach this. Maybe you don't use pandas. Maybe you do everything with some Seaborn, or you use NumPy, or you just do it all in a for loop and you calculate all your own calculations. Either case, make sure you document it, your process, and make sure you clearly state your answers. And then the last thing we're up here again is make sure you state the proper output. Again, what kind of average you used, using the correct output, the correct amounts. For example, Great British Pounds, not US dollars. Don't put the dollar sign. So anyways, that's just sort of a way to approach this. And you can take the same approach with Titanic Part 2. It's a little more work now. We have loss versus survived by sex, loss versus survived by class. So those could be visuals, those could be ratios, those could be percentages. And then calculate the conditional probability that a person survives given their sex and passes their class. So you can see this is really, these are sort of a higher level of this last one. But again, only 3 questions, but there's a little more work here to do. But again, take your own approach with Titanic Part 2. And you might borrow some of the same process you've used for part one and maybe explore that further, or you might use something totally different. So again, hopefully this was helpful, and thanks for watching.